All right, so we got an intro to Git talk. You guys have been here for a little bit, so you've been hearing us talk about some stuff. So what is Git? If you run man Git, it'll tell you that Git is the stupid content tracker. I thought that was pretty funny because I saw that on a website and I was just like, did they just make that up? And then I actually ran man Git and it actually came up. That's the first line in the man page. But the more general definition is it's a modern distributed version control system focused on speed, efficiency, and real-world usability on large projects. So to break that down, so it's a distributed version control system. So a version control system essentially keeps track of changes to files. How long does your camera last for?
15 minutes, but that was like 15 minutes.
Yeah, that definitely was not.
Do you need to change something?
No, we're good.
Okay. So a version control system keeps track of versions of a file. And then distributed just means that you can use it on multiple computers to keep track of the same files. And it's efficient with, like it tries to focus on efficiency for speed and like changing back and forth between change sets. So that's why I talked about like the large projects. They want to be just as fast with large projects as they are with small projects. So the first question, whenever I'm talking to anybody about Git is, oh, I've heard of that. That's GitHub, right? Or GitLab. And it's a super common mistake, like I said. Everybody I talk to about it is like, oh, I've heard of that. It's GitLab.com or GitHub.com, right? No, well, it's different. Git is software that you run on your computer. GitLab is a web service for online collaboration. So it's built on top of Git. It uses Git as like to keep track of all the files and stuff, but it builds on top of that and kind of adds not necessarily a social media aspect to it. Like I said, like a work collaboration, lets you collaborate with other people on top of the features of Git. So Git is software you run on your computer. GitLab or GitHub is a web service that puts a beautiful front end on it. So who should use Git? So now we kind of know what it is, but who should use it? Well, anyone working with code, any coding project on any platform, you definitely should be using Git. You can log changes, go back versions. It just makes it so much easier if you're doing types of stuff like that. So anybody that wants to track edits to a text file, this could be configuration files on a server. This could be your configurations on your Linux desktop. It could just be edits to an actual plain text file you're making. Anyone who wants different versions of the same file. So if you want to try something new with a file, like a text file, let's say you're a writer and you want to write something new, but you want to try, you're not sure if this branch of the story is going to be right. You can do that. Use Git to keep track of that. Or anyone needing to share with collaborators. Git makes it super simple to share your code, let other people change your code. Then when you get your code back, you can see exactly what the changes are, which files they changed, what exactly in those files they changed. So now we know what it is, we know who should use it. Let's say you need to use it, how do you install it? Well, on Debian-based systems, apt-get install Git, it's super easy. On Red Hat-based systems, yum install Git. On Mac and Windows, you go to ubuntu.com/download. Just kidding. If you go to git-scm.com/downloads, that's where they have binary packages for all the systems, Linux, Windows, Mac. I think they even have BSD there too. So things Git can do. You can review the log of changes. So let's say you make 5 changes. Each time you make a change, you record that change to Git. You can go back and see, here's all the changes I made. Here's the comments I made. And then you can even go back and view the exact change that was made in the code or in the files. You can go back and look at all that. You can view differences between versions. Let's say something broke, but broke 2 days ago. So you can go back in the logs, see what the 2 days ago, which changes were made, and look at the differences between each of those changes to say like, oh, here's where it broke. You can retrieve old versions of files. Let's say the client says, oh, we don't need this page on this website anymore. We want to delete that. You just delete it. Then, 3 weeks from now, they decide, well, oh, I wasn't actually supposed to tell you to delete that yet. We're not deleting that page yet. Bring it back. You can just go back, get that file again, bring it back. It's like it never left.
Does it work for emails?
It does not work for emails. I guess it could work for emails.
It works for drafts of emails. Not sure the actual emails themselves.
Well, emails are just plain text message, like plain text files. So I guess you
Depends on how they're stored.
they're not. Yeah, I guess it depends on how they're stored. If they're stored in a database or stored on flat files, but.
As long as it's not an Outlook or Exchange, it's probably a text file.
You can work on multiple versions of the same project. So, so let's say you say, I want, like I was talking about before, I want a new feature on this website, but I want to keep the main thing. So the way that when I first started at the company I wanted to, if you ever were making a change to a file, you would copy the file and put like hyphen your name, and that was your file. You could change that. The problem then comes when I'm making changes to a file and somebody else is making changes to a file, and then I overwrite the file, and then the other person finishes their changes and they overwrite the file. They just got rid of all my changes. So with Git, I could be working on changes on my computer on that file. Somebody else on their computer could be working on the exact same file, making whatever changes they want, and then Git knows how to merge them back in together after all the changes are made. You can also keep track of who made edits, so you know who to blame, and we'll get to that later. Commonly used with Git, I mean, web projects. I mean, HTML, CSS, PHP, I mean, Node. I wrote these slides a while ago, but Node would probably be one today. Ruby, any plain text coding language, definitely you should track. Even compiled languages before they're compiled, so C, C++, Objective-C, stuff like that. Even Java. Before you compile it, you keep track of that code. You don't necessarily need to keep track of the compiled code, because if you have the code, you can always build it again. Or plain text. So like that would be config files. Can I go back? No. Okay. Yeah, plain text would be like config files or things like that. If you have like a flat file database, maybe you could even, I don't know, I've never used it for a flat file database, but something like that might work for it. Things Git doesn't play well with, so binary files. Images, if you change 1 pixel of color in an image and save it again, if you didn't have the exact same compression settings with the exact same program, with the exact same so many variables, the entire binary is going to change. So it's really hard to keep track of something like that. Same thing with movies, music, and fonts. If you resave out a file, the whole file is going to be changed. And it's a binary format, so it's not like you can track like line 1, line 2, line 3. It's just one big binary blob.
Just to be clear, you can use Git to do versioning on binary files. You're just going to get a complete copy of the file every time you change it. Whereas if you use something that is a text or understandable format, it will be stored more efficiently.
Exactly.
And you can't do comparisons between binary files.
Yeah.
But lots of places I've worked insist that binary files are stored in version control systems, and
I mean, for websites,
they're religious.
For websites, we put images and things in. We don't put like PSD files because they're huge, but we put images in. That way, when we like push it to our GitLab server, everything gets deployed to the website. The images are in the repo. It just pushes it straight to the website.
I've had clients that I've dealt with that have put firmware, the hex or binary files that are going to go into some device in it, versioned. I've had them literally insist on putting the tools, the compiler or whatever that they're using into version control. Not my idea of how you should use it.
Well, that way
it will work. You
get
you get big repositories that way.
Really fast.
Yes.
There have been vendors that I've dealt with that have insisted on having all the source in Git, but they had to actually place binary tarballs of the result of the build into the Git.
Yep. You can do version control on things that are stupid to do version control, and it will work.
Yes.
All right.
Yeah.
Just
so you can put binary files in, but like you were saying, you have to copy the whole entire binary file. You can't do diffs on it to see what changed.
Right.
Things like that. Other thing, and this is, so I added interpreted formats on here for a specific reason. Like Microsoft Word documents. So when you open a Microsoft Word document, you look at it, it's just plain text. But it doesn't actually save in a plain text format. It saves in a binary format. So
actually, it doesn't.
It doesn't? Well, okay.
The newer ones don't.
The newer ones
DOS, yeah. They're like a docx or whatever it is. Yes. So they're technically XML.
Technically, it's a zipped XML.
Yeah, it's a zipped, well, if it's a zipped XML, then it is. Yeah. It is a binary format.
It's compressed binary. But if you change it to...
It's a recognized form of compression.
It doesn't play nice with Git.
It does not
Spreadsheets are the
claim
same
that.
thing. And this is one thing that I think some people have.
Yes.
This is one thing I think people have problems with because like they click on it and then they see text on the screen, but it doesn't actually save to text.
And
So like
we really
spreadsheets, oh, it's just a
wish-
bunch of numbers.
I don't know about Photoshop files, but the other three of them there, I would really wish to actually have a version control system that really did allow us to put those kind of things in
I think
and do diffs.
Microsoft has stuff
Yeah.
that'll do diffs on Word
You're
documents.
talking about standalone tools.
Yeah.
I'm talking about a version control system.
Right, and what we're
Well,
saying is that like Office
if-
Professional has
Yeah, I know
those
you
different
can
No, if you
inside
throw,
of-
if you throw them into SharePoint will do version control on.
Yeah, I don't know what they are, but I know that there's a way to do diffs on Word
But you have
documents.
to, yeah,
You have to have the software, you have to
It's
pay the
not
license.
It's not pretty. Anyways,
Alright, so now we know how to get it, what it's good for. Let's go over some configuration. So you can configure anything for Git on multiple levels. You can have system level, user level, or project level. And this is very handy because let's say you're part of GitLab and you want to use your GitLab or like email address for one project, but then for another project you want to use your personal address. So in that project level, you can use separate like username or emails for stuff like that. So username, preferred text editor, color prompt, aliases, these are all configurable on all of those levels. The next thing is 2-tree versus 3-tree architecture. So older version control systems use a 2-tree architecture. This uses a repository and a working area. Think of the working area as like the files on your disk, and the repository is like the actual stuff that's being tracked, like the old changes. So you save a file
So,
direct.
I'm just curious, so should that be 2-tree tree or 2-tree 3?
2-tree versus 3-tree architecture.
2-tree,
Two?
3.
2-tree
3.
versus 2-tree, or 3-tree versus 2-tree architecture.
There's
2-tree.
three
I
words.
see what is 2-tree 3.
And you have 3-tree tree.
Dr. Seuss flashbacks.
Yeah,
Okay, I'll change that later. It's 2-tree and 3-tree.
It also
That must have been a
has
copy
to do with
pasta
networks.
error. I have
We're
no
okay.
idea what happened there. Yeah, I don't know what. Yes, 2-tree 3 there. 1-tree, 2-tree, red tree, blue tree.
Yeah.
I thought you were talking about the title, and I'm like, I think I got the title right, but okay, I see the
No,
bullet
the
point.
headings.
Got it,
The bullet
okay.
points.
Completely derailed.
Yeah.
So
So
sorry, but those things actually trigger me.
I'm glad you pointed it out. I'll fix that. Now, why does it say continue? Oh, it's continue on to the next one. Okay. So 2-tree architecture, you save directly from your working area to the repository. With a 3-tree architecture, you can save from a working area to a staging area, then to the repository. This comes into play a ton, especially if you make like a bunch of changes, but you only want to stage part of those as a commit.
Add it to starting index, maybe?
there's also add-ons.
Staging index. That's supposed to be
Staging
staging.
index.
All right, I got to go over this slide. This slide needs some polish. So advantages of 3-tree over 2-tree. You can work on multiple files and then put them into separate commits. You can double check your work before actually making a commit out of it. And you can manipulate a group of files outside of the working index. So essentially you have an area that isn't your working index and isn't the repository that you can do things to files if you need to. So this is how Git moves things from the working directory to the staging area and then to the repository. So if you do a git add, which we'll get into the commands in a second in the demo, but you have your working directory, that, like I said, is the files on your hard drive. If you do git add, that will add it to the staging area. And then if you do a git commit, it'll take anything in the staging area and put it into the repository. Branches. Wait a second. 15 minutes left. All right, so branches, Git does them very well and Git does them very fast. There are other older systems that don't do branching and merging very well. There used to be, I'm trying to think of who it was that was giving a talk on Git before, and he's like, Fridays used to be reserved for merges, like just all day, everybody would merge, the whole office. We didn't do any work, we just merged all the changes in. And he's like, that was the whole day. It's like, with Git, merging branches is super quick. I don't think I've ever had it take more than a second. It's just, even for big chunks of code. And I'm sure things like the Linux kernel merges might take a little bit longer than, a website, but I've never had any problems with getting Git to do merges at all. It's also convenient. Branches are super convenient because you can, like I was saying before, you can work on a totally new change on a separate branch, make a couple of commits, let's say, then you just figure out it's not going to work. So you're...
Well,
is the SD card full or something?
No, I think we're good now. Maybe I didn't hit it right last time. Go ahead.
Okay. But I forget where I was talking about. Oh, so let's say you take a branch of a website off onto a totally new thing, and you decide that it's just not going to work. You can always just go back to what the old version was. A lot of these things I'm going to relate to websites because I do a lot of websites. So let's say a client's like, oh, I want to see what something like this would look like. You don't have to change your main code. You can fork it off, make a separate branch, and just run with it. See how far you can go. If it works and they like it, you just merge it back in. If it doesn't work, you just delete it. No harm, no foul. All right, now to the good stuff. It's demo time. Try to open up all the demo files. I did open it. Okay. Figure out which end this comes off of. Documents. All right, so I'm going to run a PHP server here, and then we can do. Actually, we'll get to that in a second. Let's just start a new thing. Let's go. That's what's in it, I think. Okay. Move down a little bit. Okay, so I don't have Git in it. So right now I'm in a folder. There's a couple of files here, and the folders are kind of hard to see. But there's a couple of regular website stuff there. Got an index.php file. We got some CSS files, JavaScript files, a couple of include files. For those of you that are familiar with PHP, so if we do git config list, that'll just list all my config. And so this is my global config. This is not, I didn't configure anything for this project specifically. So you see my name, there's my email, I have my editor set to Vim, and my push default is set to simple. So those are all on the global level. So if I wanted to change what my email is, I could do git config. And the way that you set that for a user on a user level is you would do like git config global and then user.name. So you see it says user.name there, and then it has my name, user.email. So you just do git config global, and the global is for the user setting. I think hyphen system is for the entire system. But then you just do whatever you want your name to be. So I could do like Alex something. And then if I do git config list again, you can see my name is now Alex something. So you can do that for your email. There's a ton of stuff you can configure in Git. You can do aliasing here, all types of fun stuff. I like to keep it simple. I don't have a ton of needs for as far as Git goes. I'll just change my name back to Alex Meyer. You can also do project level stuff. So if I do git config and I don't give it any flag for global or system, and I just do user.email, I can do like a@a.com. Oh, so it's telling me that it's not a Git,
You have to do that.
not a Git repository. So it has to be a Git repository before you can set up settings for it.
Did you bump the font size?
So what? Oh. Apparently not. Control plus does not work. Doo-doo-doo. I'm not sure even how to bring up the menu for this. Terminal, preferences.
What term is it?
Show menu bar.
Looks like something in Ubuntu.
It's good enough. It's GNOME terminal. This is
Then
Fedora.
there should be edit preferences.
Yeah. Profiles and codings, shortcuts, general. We're going to profile?
Yeah.
Yes. Terminal size, colors, scrolling.
There's a font there somewhere. You might have to unclick system.
Custom font. There it is. Okay.
Yeah.
So I got to use a custom one. So let's do size.
It's using assist
Control
first.
plus, I thought used to do it.
No, you have to, there's a checkbox, and if you just matches the system configuration, you can't change
There
it.
you go.
But if you, yeah. Those of us with almost 60-year-old eyes, like, know these things. My wife just bought
Yes.
some HP with a, like, almost 4,000 by 2,500
It's a 4K
display.
Yeah.
I brought, like, Debian up on it the first time, and I'm like, holy fuck, the
I thought-
text is like that high.
I thought Control plus. Control minus works. Oh, there it is. Control Shift plus.
Right, you might actually have to hit plus.
What? I was pushing plus. It's Control Shift plus to go up. It's Control minus to go down.
No, plus is shift.
Oh, plus is a shift.
I see. Okay,
That's
so what's
why
Control
that's
plus?
why the equals were coming up.
Yeah. Okay,
If you had tried on the numeric keypad, it might have worked.
Nope.
Yeah.
Okay, so but now that it's bigger, I get keyboard. Where were we? Git status. Okay, so we don't have a Git repository. So the way that you initiate a Git repository is you just do git init. Or before I do that though, I'm going to list all the files in this directory, and I need to pick a better color scheme, but we'll deal with it. So there's the CSS folder, fonts folder, ink folder, JavaScript folder, and PSD folders. There is no folder called .git. So when you do git init, the only thing that it does is it initializes an empty directory, and then you can see at the end of there it says .git as the directory that it created. So if you do ls-la again, you can see right here, take my word for it, there's a git. I don't know if changing the color scheme would matter here.
Yeah, don't do it right now.
Say what?
Don't do it right now. Just
Yeah.
no.
Okay.
Yeah. Aside from the blue, everything's fine.
So then if I do git status, it shows me all these red things here that, one sec. I swear to God, there was just something here for light or dark color theme. Oh. Oh, God. Is that better?
That's
That's better.
All right.
Actually, you know the most
Thinking
readable
back
color
at Georgia
screen is
Tech with the
actually
green
white.
TTY.
It's actually white on blue.
White on blue. Okay.
Yeah, which, you know, for Windows people, that's usually, we're going, okay, that looks like the blue screen of death, but but it is, they have done studies and they have found that white on blue.
Usually I change my terminal to white and I just have all dark colors, but it looks alright on my screen. It just, this projector screens are always like that.
Well, right.
But so you see right here, where'd it go? I did git status. Okay, so ls-la. So you can see here then, there is a git file, .git folder, which you can cd into and then do ls. And then you see, it just has all this stuff. So this is all the stuff that Git needs. you rarely ever have to come in here to do anything. I've never actually had to come in here except for when I was setting up hooks for things. But for just basic use, this folder doesn't matter.
And
You just
generally, if you're going into there, you need to be
Hey,
extremely
bring your
careful
wizard hat
because
and
something
your
bad is
staff
about to
because you need to
happen.
do some magic.
Right.
Bad things have already happened or they're about to.
Or they're about to.
So when I do git status, it will show you that these are all the untracked files. So this is the branch we're on. It's telling us that we don't have any commits. This is the initial commit, if we would make one. These are the untracked files. So these are all the things here that it has not tracked yet, but are in this directory. So I can do git add, and I'm going to add dot, which is everything in the directory, and then I can do git status. I can type. And then you see that all of these, it's saying this is a new file, this is a new file, all of these are new files. Literally the entire directory is new files. But when I did that, I realized, oh my goodness, I don't want to keep these in here. So this is one good thing. I didn't have to commit that. I can stage it. This is the staging area. So all these things are changes to be committed. And Git is super helpful whenever it's like, this is how you want to stage stuff. So it's like, I have stuff here that I don't want. I don't want this stuff. So I can do git reset and PSD, hyphen PSDs. I swear that's 4. PSDS, yeah. Git reset hyphen PSDS.
Escape the
Isn't
dash.
like the dash.
Ah. No.
What's the-
Magic dash is. So then if you see I do git status, now I have this down here that's not going to be staged, and then all of this stuff up here that is going to be staged. And you notice that I already had this file here. This is left over from a previous demo, but I have a file called git ignore. So if we edit that, we can add -psds/ star. So anything in that file, or actually I think we can just do that. Let's try it. So I'm adding things that I don't want Git to track. So Git doesn't even need to worry about it, doesn't need to tell me they're not tracked, doesn't need to tell me they changed, doesn't need to tell me anything. I just don't want to know about them. So we're going to add that to the git ignore file. And then if we do git status, we'll notice that this file was modified because we already had these staged. This was modified, but there is no PSDs folder down here that's trying to track. So if I do git add dot and then do git status, we'll notice that the PSD files are not here because it's in git ignore. Git just doesn't care about them. Knows that folder's there. It doesn't even care. It's just anything inside there doesn't matter. So that's helpful because like you see, I'm doing git add and then the current directory. I can add everything in that directory and it just won't add anything that's in the git ignore file. You can do things like you can put stars there like you saw I was going to do. You can even do like ** and then like whatever hyphen PSDs. That way you just ignore every PSDs folder in the entire folder structure. It's because when you're dealing with artists, they like to leave files. They like to add PSD folders just wherever they feel like it. So they don't always put it in the root of the website. So now we have stuff in the staging area. Now we need to get it into the repository. So if you remember the chart from before, you do git add to get it to the staging area, and then git commit to get it to the repository. So you could git commit, and then this might look intimidating. So I'm in Vim. It adds all these as comments, and that's just telling you these are the files you added. Please enter your commit message above. Anything that starts with a £sign will be ignored. So we're going to add initial commit. We're going to add that as the commit message. How many of you guys have used Git? Okay. I just want to make Jason, have you used Git?
Like really? Like really?
Okay. I just wanted to make sure I wasn't going way too slow for you guys.
Yeah, the guy that works for GitLab
Hey,
has never used it.
No.
Your
God,
camera.
no.
So,
All right, so
Okay.
back up. I do have a question.
Okay,
You
absolutely.
mentioned earlier about 2-tree versus 3-tree.
Yes.
So Git is always in a 3-tree mode.
There are ways you can get around it and use it like a 2-tree, but yes, it is. There are flags, so I can do Git.
The way
yes.
the way that slide was talking was I sort of got I got
Oh.
the impression that it could be run in either mode.
What I was getting at is older version control systems. I think the camera clicking kind of got in the way of there. It didn't click right now, but older version control systems just use a 2 tree. They were like, you have files on your directory, we want to commit those to the repo, and it would just straight up push them into the repo. So all those green lines there that said like new file, new file, new file.
Yeah.
If you just want to add one at a time, that is the middle, the third
Yeah.
tree. So that's the staging area. So yeah, you can use
No,
it.
I get the difference. It was
Yeah.
just.
But it
You
gets
can do it. You
worse
can-
than this because, as Plum said before we started, and I think before you arrived here, you also have a get workdir option, which allows you to essentially have multiple different, I would call the working directory as sandbox,
Yes.
because that's what a lot of other version control
Yes.
systems use.
Essentially.
And then separately from that, there are add-ons for Get, like one of them that I'm familiar with is Get Stash, which
Yes.
essentially allows you to have a kind of mini version control system inside of the version control
Oh.
system. So you can like be messing around with files and you can stash your changes. And now you have basically version changes that are not, the changes Git doesn't know about them yet.
Uh-huh.
So
Yeah.
you can then you push them into your stash, and then you can pop them out of your stash one at a time and commit them as you want. So now you essentially have 4 trees,
Uh-huh.
or 5 trees,
Yeah.
or
Yeah.
a forest.
Stash
It has-
is
it
super handy if you
I think
just
there's
went,
another one
oh
besides
crap,
stash.
I'm
but
on
that's,
the wrong branch.
Yeah.
well,
yeah.
I
Git stash, suck it all up,
Uh-huh.
check out the right branch.
I do that
Git
all
stash
the time.
plot.
It's
Oh,
like
phew.
I use stash because if you're trying to do anything that you're like trying to push into like Linux kernel or some kind of public repository, they want their commits well structured.
Uh-huh.
You don't just go, oh, I've made important changes, commit,
Uh-huh.
you know, and save my ass. You know, so if you were doing that and then you're preparing a patch to go into the kernel, now you've got 50 billion things that are, or maybe there's a tool for that, but I don't know.
Well, I'm
how
going to say
do
so.
it.
So with the 3-tier thing, you can add parts of files to a commit. So you can add 2 lines out of one file to a staging area, and then just commit those 2 lines. You don't have to add the entire file, and you don't even have to do like I was doing git add and then the dot, which means everything in the current directory. You don't even have to do that. You can give it a single file name,
Right.
or you can use the -p flag, which means part. And then you can do, so git add a part of this file, and then it'll literally walk you through the file. Do you want to stage this? Yes or no? Do you want to stage this? Yes or no? Do you want? It'll just step through each part of the file, and you can just stage like one piece of it if you wanted to.
So if you're, so as an example, if you have a file and you're making a large change, but you need to change a bunch of variables and then say fix white space.
Mhm.
Don't change all of your code and the white space and then commit it all at once, because the guy who's reading your changes will hate you because you changed every line instead of
Yeah,
just the lines
exactly.
you're changing.
Yep.
You take this function that got changed, commit that, and you take this set of routines that then got changed because of that name change, and you put that over there, and then you fix the white space
Yeah.
in another commit.
When
And
you
can
do
all of this at once,
Uh-huh.
except for the white space.
yeah.
And there's a way to do that with ignore white space.
Okay.
And then you can do all of those things individually. And then you do the last commit that is actually the whole thing with the white space changes. So people can look at your merge or your patch and go, oh, okay, now this is actually functional. It's not him changing the entire file.
Uh-huh.
Because if you've got 5,000 lines of code and you change the white space, that hits 700 lines, and the guy who's reviewing the change knows you were only supposed to touch 3 functions. How did you hit 700 lines?
Yeah. So we just made a commit. So if we do git log, we can then see our commits. And this is what the log looks like. Every commit that we have will have a hash assigned to it. This is very important because that does, it makes sure that no part of your chain is corrupted. Every commit after this will have that hash as its parent. So since that hash is part of the next commit, we know for a fact that that was its parent. You can always double check that. You can go the whole way back to the first commit in the repository, following each hash for each parent, and you know that every step along the way, you can validate that the step before it is the actual step. So you know you have a change. Somebody couldn't sneak in a change somewhere and just split it in between things and then add malicious code in there. You know that every commit was built on top of the commit before it. So each commit has a couple of parts. Like I said, it has the commit hash, it has the author, so that tells you who it is. So here's my name, my email address. It has the date that it was made and the time zone you were in. We're in -5. I'm not sure if that changes for daylight savings time or not.
Yeah,
I never actually checked that. Does it go -4?
Mm-hmm.
Oh, okay. And then here's your comment. So this is the title of my comment. I haven't showed you how to fully make a comment, but this is technically the title. The body of the comment. You can also have a body that would be a blank line in the middle, and I'll show you those in a minute. So that's essentially how to initialize a repo. Now I'm going to actually go to a repo that we already have, set up, and if I do git log here, you can see that here is a bunch more commit messages. So they go reverse chronologically. So the bottom is the first one. So down here I have the initial commit, has a hash, the author, blah, blah, then update the web page, and then Jason made a commit here, he added a navigation to the website, and then I updated the homepage copy, blah, blah, but you can see dates, times, everything's good. So I'm going to go through a fake scenario where we have a client that wants a bunch of stuff done, and we're going to make some of those changes. Let me open up. Whoopsies. So I'm going to open up Atom, which is my text editor of choice. And of course, this is a dark theme also. So here we have our test website. It has a couple of files. It's got Bootstrap in here. It's got a little tiny bit of custom CSS, some other stuff. But let's open. I thought it was called email. Oh, client email. Are you serious? Oh, I see what to do. Okay, so CD test. There it is. All right, so I have all these fake emails that a client sent me so that you're going to kind of go through a real world scenario. So here's a list of things we need to do our website. Actually, I should probably show you the website, or the fake website. Let's do, okay, 881, all right.
You went to 881.
Okay, so here's our fake website. Looks pretty simple.
Yep.
Client, yeah, super simple. It only has one page on it, but our client's sending us all these emails. So essentially, let's say we just started a project. That's our first draft we sent to them. Here's what we could look like. What do you want to add? So here's a list of things we need on our website. Can you have this done by the end of the day, which is totally a reasonable time frame? We need to create an about page. We are some company, and this is the copy that they're sending for that. We are some company that does something, blah, blah, blah. We would also like to contact us page with a pretty form on it. So it needs name, email, and comment, and then they need to send the email to me at companyname.com. Sincerely, the client. So let's start doing those. So you'll notice that we're on the branch master. So git branch will list all the branches. There is only one branch, just branch master. So if you want to create a new branch, you can do git branch, then branch name, whatever you want. And then if you do git branch again, you'll see that it made a branch called bname. Now the star next to this shows the branch that we're on. So then you would have to do a git checkout and bname. And then now if you do git branch, you'll see that the star is next to the branch that we're on. We're on branch bname. There is a shortcut for this also. So you can git checkout master. And then, so let's say we're on the master branch, we want to make a new one and switch to it at the same time. You can do git checkout -b telling you we want a new branch, and then the branch name. So we'll do feature / about us, because we're making it the about us page. So then if we do git branch you'll see that there's 3 branches, and so we were on master, we created a new branch and checked it out all at the same time using git checkout-b, the star's next to here, so it does it, it's kind of like a little shortcut. That's the way I always do it, but you can do branch name and then give it a name and switch to that. So now that we're on a separate branch, what's different? Do our files look different? Is our website still there? The website's still identical. I should probably open up the file. We don't need files. I guess I have it here. The files are still identical. Nothing has changed. All that happened was Git thinks that we're on a different branch. So it's just going to track things in a separate branch, a separate kind of like mini repository within a repository. So now let's make the changes they made or requested. What did they request? So they want an About Us page. Let's go get that. Make an About Us page, and here's a podcast. So let's copy these.
With terrible spelling and all.
We need the terrible spelling. I'll give you an example later. Well, it's part of the next come email. You're working ahead. Stop. So, oopsies. Come on. So I'm just going to copy the index.php, and I'm going to copy it to about us.php or about.php. I forget what I meant. Whatever, we'll just make it about.php. And so then if we go back to our text editor, we see now we have this about.php. And so I'm using Atom, and I'm not sure if you can see this. This file right here is green. So Atom is Git aware. It was made by the same people that made GitHub. It tells me this file is green, I added it. So I can see right in this file what all has changed. Or right in my editor, which stuff has been changed. So I'm going to change this line here, and I'm going to change this to About Us. And I'm going to change this to About Us. Okay, cool. So now we have a decent little About Us page. So then if we go to here /About Us or about.php, boom, there's our About page. Cool. And you'll notice that the title up here has changed, everything changed. That looks like a pretty good About Us page. So then what we're going to do is they also want a form. I actually have that. So we're going to cp
CP.
PC. CP
He's just copying the reverse.
Oh, yeah.
We're just putting the file the other way. The parameters are switched. So we want to copy. I thought I had contact us. So we want to copy contact us, and we'll copy it here. So we just copy that there. If we go back to our text editor, we'll see now we have a contact us. Has contact us. I already put the form out there because I don't want you guys to watch me sit. Hey, Nate, your thing went off. Oh. I should have brought my. You should have told me. I couldn't have brought my camcorder. I have a recorder though. So now we've added a bunch of files. We've changed a bunch of files. Let's do git status. And you notice, so I'm using ZSH here with ohmyZSH. So this little yellow X here means that I have changes. This is the current branch that we're on, and this little yellow X means that I have changes. So if you do git status, this will tell us all of our changes. So these are the untracked files. So we have not tracked these files yet. These are Git sees them, but it hasn't ever interacted with them before. So, well, since we made changes, we added them, but you'll notice I'm on the About page, but there's no links here. Let's also copy. So we're going to copy that. So I just copied a header file into here. The only thing that was modified in that, which actually let's just refresh here so I can show you. Oh my. That was feature change. We'll just ignore that for now. But I added these 2 links, so now you can go to About and you can go to Contact Us. So I just added the navigation in the ink/header. And you notice this file is yellow, so that tells you that. I might be skipping ahead because all of this changed. So, but this file is yellow. That means that this file was here, and just these lines with this yellow line beside it. These are the only ones that changed. Which, let's undo that real quick, just a second. Where was the demo? Let's look at what it was like before. Holy smokes! Somebody doesn't know how to indent. So this is where git blame comes in. This is horribly formatted code. So who the heck did that? So we can do git blame and then a file name here. So ink header, and just see who did it. And everywhere, oh my goodness, Jason. And this is when he did it. And it goes for every single line of the file. So you can go, you can whittle this down. This is the commit that it was made on. This is who made it. This is when they made it. Jason didn't actually do this, but we can blame Jason. So that's what the file looked like before, and then we can go back up. Let's copy that, and so let's do git status again. And you'll see that since that file was yellow in Atom, that means that it was modified. All these lines were the ones that were modified. And then this tells you, so there's two different sections here now. So this is changes that are not staged, but it tells you this was modified. So the inc header was modified, and then these are untracked. So now you see that it knows which files it already has track of, which files it doesn't. But we want to add all that, so let's just do git add dot. And then if we do git status again, you'll see now there are changes to be committed. So these are all in the staging area. This is a new file, and this is modified. So again, we do git commit. And then here we make a commit. So this is going to be a little bit different of a commit. And I haven't talked about how you make your commit messages. Commit messages are very important. Commit messages need to be like straight to the point, concise. You don't want to write like a novel in here. Each commit has a title and a body. The bodies are optional. They're more for extra stuff that you want to let the person know about this commit. But the title, you have to have a title. You have to have something in the commit message. You don't want to just make commit messages like made changes. You want your commit message so that when you're going back to look through your history, you know what happened in this change. So I made two changes here. I made a contact us page and a about page. But we're just going to make it one commit just to keep this easy. So create about and contact page. So you'll notice I put a blank line here. If I start typing, it lets me know that that's red. That's no good. You have to have a blank line between your title and your body. Commit messages also should be like present tense. They should not be created or creates. It should always be, it should tell you what the commit does, not what it did do or is going to do. What does this commit do? This commit create about page and contact page. It doesn't creates or created, or it always should be present tense. So what did this commit do? Create, about, and contact page. The body is a little bit, it depends on who you're talking to. Some like open source projects say you have to have an issue number in your body. You have to do this other stuff. So if there isn't an issue for whatever you're trying to do, you have to open this issue. Different companies might have like reference numbers for tickets you put in here for their ticket tracking system, but you can really put whatever you want in the body. So client supplied copy form sends to the ad company. Whatever. So you can put that stuff in there. All this stuff is searchable, so if you ever have to, this is why you want your commit message, like I said, to be brief, but you want it to have all the information you need. So if you want to know where you added the contact page, you can search your history for where you added the contact page, go back to see exactly who did it, when they did it, all that stuff. And you'll notice that the yellow X here is gone. So if I do git status, it says I'm on the branch feature about us, and I have nothing to commit. My working directory is clean. So if we look at the working directory, we see all these files. But let's say we were in our about file. So far we've put stuff into the Git repository, but what is it actually good for? But like, let's say we're on our about page and we accidentally like delete the entire page, and then we close our editor. Oh no. We see about was modified, and we can do git diff to see exactly what was modified. All this stuff was deleted, but how do we actually get it back? Like if we open up our editor again, and then we go back into about, we see it was edited, but we can't get it back. This red line's here, like that's where the stuff should be, but how do we actually get our stuff back? Well, we can do git checkout about.php. And then we do git status. We'll notice that it's clean. And if we go back to our editor, holy smokes, all this stuff came back up. That's awesome. So this is why you need Git. If you make a horrible change, or somebody deletes something like on your system or whatever, Git will have your back. So that's cool. So we can get the copy back from if we delete something or misplace it or whatever. But what if we actually like What if we actually delete a whole file? Well, git lets us know that this was deleted, and you can do the exact same thing. Git checkout about.php. And then if we do git status, working directory is clean, about.php is still here. So anything in the repository you can always retrieve as long as that .git file stays there. Or if you have a remote branch, you can pull down from that if you need to. You can check it. You can check out the about.php from a remote server if you have that. If it's deleted and you lost Git on your, not all hope is lost. Or a previous version will be somewhere. So the client had other email changes they want. So client email to. So there's a typo on the about page because we had a proofreader over there. He noticed that too. So sell should be sell, definitely should be definitely. We're also sponsoring cats for the next month. Can you add the attached image as a header to our website, the client? So in here, we'll notice that a commit should be one ideological set of changes. It shouldn't be, so the client's asking for two things here, but really we want to make those two separate commits. We want to add the cat image as a header, and we want to add the spelling changes as a separate commit. So, okay, so let's do that. So, on the about page, sell should be sell, and definitely, I forget how to spell definitely. We'll call it. Is that right?
Does Adam have spell checking?
No, it doesn't
That
have
is
spell
not.
check. You can't spell check.
Vim has spell checking.
I don't do proofing. Vim has spell checking?
Yes.
Yeah, you just have to add it. You
I
can
can
spell.
Here I'm using.
There's a Vim
We're talking
add-on
about Vim, and I'm
for
typing Vim
everything.
shortcuts to
I
saving.
mean, hell, I think there's a Vim add-on to play tic-tac-toe inside of it.
Okay, so in Atom, you'll notice that this is the only line that turned yellow. So this is the only line that we edited. Vim doesn't tell you exactly what we edited down to the word, but if we do git status, we can see that we modified our about file, and if we do git diff, we can see what the diff is. So this line here was subtracted, this line was added. Well, only part of it was, but git tracks the whole line. So as a patch, that's what it would look like. So let's pretend we're just working ahead, and we're going to add our header file. We're going to add the cat to the header. I forget if I have a.
I thought you were supposed to commit.
Well,
Oh, you
hold
did
on.
commit.
I'm going to show you the three tree example.
3-tree key.
1 tree, 2 tree. How many trees? Documents. All right, so I'm going to drop this in here, and I'm going to drop that in there. Okay, so I dropped 2 files in here. I changed index. On index, I added this block right here, which essentially adds the cat picture that our client supposedly sent to us. Here's the cat picture. They're sponsoring cats this month. So we need some cat pictures on the website. So let's go back to the website before we actually commit that. Here's what it looks like. We added the cat picture. If we go to the about page, sell is spelled right, definitely spelled right. So now we have multiple changes that we made there. So let's go back to the terminal and do git status. You'll see that all of these files are edited. It has an images folder that we added that is not tracked, and about is edited, and index is also edited. So, but we want those to be 2 separate commits, like I was saying before. So let's make the about change first. So let's git add about. And then if we do git status, you'll see that about is in the staging area. This is still modified, but it's only in our working directory. It's not staged for a commit. And images is not even tracked. So the only thing in our staging area, the only thing that if I commit right now will be committed is the about.php file. So let's do git commit. Up here we're going to do spelling, fix typos. Let's do fix typos. Fix typos on about page. So then if we do git status, you'll see that these 2 changes are still here. About.php went away, but these two changes are still here. If we do git log, you can see that this is the last one I made. So you can make a bunch of changes to your actual code and then just take pieces of it or one single files and add those to the repository. Whereas before you would have had to, undo and save different versions or copy files out, move them other places, and then just commit whatever your working directory was and copy our stuff back in. With Git, you can have as many changes as you want and just commit individual pieces of them. So now if we git add dot, git status, we have images we're adding, and so this is a new file. I don't know why it still says on track. Oh, sorry. Yeah, here's git status. Start here. So we have a new file. We have this cat picture, and we have the index.php. So let's git commit add. That's not how you're supposed to.
Okay, I'm going to ask if I'm
Okay.
getting ahead of you again, but shouldn't that really be on a different branch?
Yes, it possibly should.
Because
I have not shown you how to merge yet. That's correct. I skipped a step. So I was supposed to merge back in and then create a separate branch, but I'm just moving right
Because
along.
I'm just thinking that this is not really part of the About Us feature.
Well, you
Very
also
true.
have to address, there's a difference between what Git is capable of doing and what is good practice or style.
Right.
You were talking about the comments as an example. There must be a comment, otherwise it will not commit.
Yeah.
Comment can be bullshit.
Uh-huh.
Okay, that's a very bad idea. All
Yeah.
right, but same thing with what we're talking about here. A branch is a good idea,
Uh-huh.
but you decide how you want to do your own stuff.
Uh-huh.
You want to do lots of branches, that's fine. You want the sexy comments following a set of rules. There's a limited amount of things it will assume about comments if you use them that way, but
Uh-huh.
beyond that you can do whatever you want with comments, like you were saying, add tags and what have you. That's company rules or style rules or whatever.
Based on your-
They
if
may
you're
be a
working on
very
an
good
open source
idea,
project.
but
Yeah.
they're not rules of Git, they're rules of your company or your personal style or something
You said
like
you've
that.
used Git before?
I haven't.
You haven't? Okay. You're picking up a lot of this for the first time. Other times I've given this talk, people are like, I don't know what a branch is. I don't get it.
I've had to administer version control systems.
Okay.
I have not I've had to deal with Team Foundation services, which actually, the version of TFS that I worked with was fine.
Okay.
It was, I actually never got around to moving it from the 05 up to some of the more later versions. And I
Had to deal
talked to
with
someone that
source
said
safe.
that,
That's called
I did.
how to destroy your files.
Yeah, I did the conversion or helped do the conversion from source safe to TFS like 2005.
Uh-huh.
The real fun on 2005 is, yes, it sort of uses the basic SharePoint services. And one of the things that they're like, oh yeah, you can run some of this on 64-bit hardware. So I'm like, all right, or 64-bit OSs. All right, fine. I'm going to install a 64-bit OS. Yeah, that only worked in that version if you did the data tier on 64-bit OS and ran SQL there, because the SharePoint stuff wouldn't run, or the web stuff was not ready to run on 64, or one of
Should have
those.
converted to Git.
That was not an
Or
option.
Not an option
Linux.
at the time.
That was not an option
Okay.
for this country.
64 bits has worked for a long time, and it's worked fairly well
Well,
with
this was
32-bit stuff mixed
He
in.
didn't have the right
This has
licensing,
been
though.
This has been a few years ago, back when that transition was starting to happen.
When was the first 64-bit Linux?
Pretty much short.
I'd imagine right after the first
After
64-bit processor.
1.4, I don't know. When did he do that? Alpha?
Yeah.
No.
Oh,
So we're
64-bit
gonna make
OS
a commit message, just add cat header to homepage. We're gonna commit that. So the one thing about I didn't show you how to merge, so I missed a step in there. So we're still on feature about us. Now our change right now depends on changes that were made in the about us branch. because we wouldn't have an about page if it wasn't on the About Us branch. But let's say that we sent this up to the client, they liked it, and now we need, I'm actually going to delete it. Actually, branch. I can't type. So we want to merge this stuff back into master. That's how, after, master is generally the branch that everybody accepts as the working like product, the current thing that's out there. Some companies have different things where they'll have like a branch named version 2, and that will be every version of version 2, and then whenever they switch over to version 3 becomes the primary branch. So you can commit to branches like that. Kind of depends on the thing you're working. With websites, generally there's only one version ever out there, so master is kind of the de facto, this is what's on the production server. But once you get into software, or I'd imagine things like Linux distros even, there's probably different branches for different desktop environments or stuff like that. But the way that you get changes from one branch to another is you do a merge. So let's check out master. And then, so I said that you could diff almost anything. So we did diffs when we were making commits, but let's do diffs between a branch. If you do git log, and then feature / about us, you can see all the logs. So these are all the logs that are on about us that are not on this current branch. You can also git diff and their branch name. And this will show you literally everything that has changed. So we got rid of a bunch of, what is this? Oh, these are backwards. I'm not sure if you can do a dot here. Yes, you can. Okay. So the dot that I'm showing you there is signifies the two things that you want to compare. By default, you're comparing feature about us if you were going from master to feature / about us to master. But by putting the dot there, there's an invisible character here. This would be head. Head just is assumed if there's nothing on the side of these dots. So we're consuming head, which is the current pointer, which is pointing to master, and we're comparing that to the changes on about us. So essentially we're just flipping the order there, and so that'll show us pluses instead of minuses. So we added a file. Right.
Head is the current where you're at now, not the current where you're at now on master.
Head points to master. Head is a pointer to the current thing I've checked out.
If you're on master, head points to where you're at in master. If you're on feature about us, it points to where you're at on feature about us.
Can you do is that a variable? Can I output head?
Like what is head?
Yeah.
No, it's not a shell variable.
It wouldn't be, but is there a way to see what it is? I guess you could just do git log, and it is whatever.
Git log -n1.
Well, if you git log, whatever. But if you just do git log, this is head. Head is the most recent thing on the thing that you have checked out.
Yeah, it's the tip of the current branch. That's what head is.
All I was after is does the symbol mean the top of master, or does it mean the top of the current branch?
Current branch tip.
I mean, I understand
and
it's a symbol.
well, I guess technically it is the current branch tip, but you can even take git off of a branch. You don't even have to be on a branch.
Yes, if you check out a tag, it'll be considered in a detached state. But yeah, head is always whatever the tip of your current checked out.
All right.
Branch, tag, whatever.
Oh, that's cool. Okay, so it's cat.git.
There's a file,
Yeah. So that'll put, and it's a reference to refs head master.
Right.
And then if you output that
head master. And this.
So you'll notice that that ID right there is, if you do git log, is this ID. I'm going to all over on the screen. So C77758AA. C77758AA. So this is essentially, it's a pointer to a pointer. But what I could do is, if I do git log and then copy this and then git checkout, I can check out that commit, and then it will complain like you're checking out this, you are detached from a head state, you are not on. But then if I do cat.git head, you'll see that it points to the current commit that I'm on. But if I did git branch, it'll say that I'm on. Head is detached, I'm not on a branch, I'm just on some random commit. And to get back to a commit, I would just do git checkout master. So if you wanted to go back to a version of your website and check out what it looked like a while ago, but you don't need that information, what you can do is just go back to like the initial commit, git checkout this, and since I'm running on server, we can go to the here, and apparently there was no about page back then, just index page, and it looked like nothing. So that was the first commit that I made, was just that. Okay, but now we have two branches. We can see what the difference was with git log feature. This tells us all the stuff that's on feature but not in master. So if we want to merge, we simply, so we're on master right now, and we want to merge all of the things into master that are on feature about us. So git merge feature about us, and Git's smart enough, as long as there's no collisions for any files, you just see that it just does a fast forward merge and just merges all the stuff here. Some companies, I'm not sure, at GitLab, do you do fast forward merge or do you do merge requests? Like a merge, no fast forward.
There's a way to do either one.
I know, but
by default, when you do
which to, and then yet again, this comes down to policies. Git has a bunch of different ways of doing things. I generally do fast forward merges because I don't care about when things were merged. I just care about like the history. But some companies are like, oh no, you have to have a merge request. You cannot do fast forward merges because we want to see every point of whatever. So how does GitLab do that?
A merge request is when it is merged is a fast forward merge.
Okay.
It will take you to your point as close as you can get that's functional, and then do the merge at that point.
Okay.
If you cannot
But does it
merge, for
make a
example,
merge
if you're
commit?
saying merge my/foo into your/master, it will actually go, okay, if I can't merge things because of a conflict, it will notice that between the state of master, not the state of master when you did your change. So it will actually try to do the fast forward merge all the time.
Okay.
That's where you get your conflict resolution, is because it's doing it in that fashion.
Okay. But there's a way, so if I do git log, you'll notice that there is no commit up here that says like, merge these two branches. It literally just took that branch, took all the changes on top of it, and put it on top of our master branch. Sometimes, like I was saying, if the branches weren't at the same level when they started, you can't put it right on top, what it'll do is it'll just have you make another merge request that kind of like brings it up to speed and then just puts everything on top. So essentially, it's just another merge on top that says like merge changes from this other branch. That's like what the default message says. Generally, like I said, I do all fast forward merges. If I need to rebase something, which is kind of a more advanced topic, we just do that so that they're at the same level so that we can just fast forward everything. But so we're still in master. When we do git log, you'll see all the changes from the other branch are now here. And you saw that took like a half a second, not even. So then if we do git log .feature, it comes up with blank. There's nothing. There are no differences between that and the feature branch, or feature about us. So if we wanted to delete that, we could do git branch -d feature about us. Then when we do git branch, so essentially we deleted that. So the -d, so git branch -d will delete a branch. You notice that that branch no longer exists. So
you made your changes in the branch, you
Yes.
experimented with it in the branch, you merged the branch back into the original, and you deleted the branch. Now the original not only has the changes, but it also has the changes as individual commits like they were before, but they're not, but you don't have the
They're
branch
not
that you did.
disassociated
All right.
anymore. Yeah.
Yeah.
Right. All right.
The
So-
way a
so
fast
the-
forward merge works is unless you take the time to do what they call a squashing commit, where you take all your commits and smash them into
Right.
one, it has taken them from over here and gone, I'm just going to put these on top.
yes.
And it still has all the individual parts.
Right.
So you'll notice that we were talking about pointers a lot. Like when I talk about head points to the tip of the current branch or the current commit you're on. Git doesn't care about which branch it is, which branch you're on. Branches, like I said, are just like mini little repositories. You can switch something over to like a temporary state, but everything in Git is a pointer. So git master is a pointer somewhere. If we have the branch B name right there, that is a pointer to a certain commit. So Git doesn't care about your
One
camera
off
clicked.
again.
Just let you
You
know.
could set a timer or something.
The max is 15 minutes.
I'm saying he could set a
Oh,
timer.
on his phone.
Time on my computers. And
Set it
But-
to like 14 minutes so he knows.
But everything essentially in Git is a pointer, so it doesn't care where you're making the commits or if you move the commits over here. It doesn't care about the branch it came from. It just knows that master is a pointer to this commit right here. This branch is a pointer to 5 commits ahead of it. So when you do a fast forward merge, all it does is takes master and just changes whatever it points to. You're not actually adding them to a folder or anything like that. You're just literally changing where the pointer points to. So all the commits are just in one spot, and then it just says like master is this, and then each commit from there says here's my parent, and then here's my parent, here's my parent, and so that's how you know how it goes back in the chain. I'm not sure if you can output parent commits in GitLog, but essentially this commit has something that says like this is my parent, so then it goes there and then it adds that to the log, and then this commit has something that says this is my
Actually,
parent.
it's kind of more like inodes in file systems.
Okay.
The commit numbers are sort of, they're the inode of a diff. Okay, and so you've got this file system that has myriads of diffs over top of it, and now the names, the branches, and all of the rest of that stuff are implemented above that in the directory system. You know, in file systems, inodes don't have anything to do with, I mean, they're just their own thing underneath, and on top of that is your directory structure with its own set of rules. And in the rules it says this name matches to that inode, and then that inode,
exactly.
in this case, links to all the rest
So,
of it.
so when you do a git checkout and then a branch name, you're not switching to a separate folder, you're not going anywhere, you're just, git is literally checking what's the commit ID on this, and then make the directory look like that. Make the working directory look like that. So that's all it does. A cool feature of this is it keeps things very light. You have, so let's say I have 20 branches, all of them have, let's say there's 20,000 commits, but I just need to make one. I don't need 20 copies of 20,000 commits. I just have those 20,000 commits once, and then each branch just reference a different point somewhere on them. They don't even have to be on top of each other, beside each other, whatever, it doesn't matter. It just references, this is where this branch points. So you only have one copy of every commit in the repository, and then each branch just points to wherever it needs to point to in the chain.
Right.
And like I said, so if 2 have the same parent, you would need to do like a rebase so that you can put it on top. But you can have 2 commits that have the same parent commit. You'd have to do a 3-way merge, which is essentially where you put it on top and then make a merge on top of that. And that's like I said, a little bit more advanced. But yeah, all the branches are just pointers to a commit. So that keeps things in Git very small. You don't have to have, for each branch you make, and branches are very cheap. You make a new branch, literally nothing was created except for a pointer file. And then that just points to a commit. No files were copied, nothing was changed. So that's a really cool thing about Git. It keeps it light and small. Let's see what the third one is here. I forget what we did for the client 3. I just realized our logo is not the navigation. That's an easy one. So the client requested something. First thing you do, git checkout -b. So we're creating a new branch. We're checking out and creating a new branch at the same time. This is a shortcut I was talking about before. So essentially, this is like I would type git branch, then the name, then git checkout, then the name. So let's do bug fix /logo. And then when we go to Atom, let's just drop in. Should have set this monitor up better. And all I'm doing right now is just copying a file, placing it there. I believe that's where it's supposed to point to. So all I did was just drop this company logo in here. You see it's green. That means that we added it. And in header, let's see if it still points there. Images /logo. So if we go back to our website, see what that looks like. You notice company logo. Cool. All the pages still work. Everything's fine. So if we do a git status, we'll see that the only thing is untracked files. We added this new file. So the Git has not tracked this, but it's here. Like I said, so the logo is a binary file. When I'm working on websites, I track the images. I don't track the PSDs because you don't really, like I said, they're huge and you don't really get much out of it. But as far as tracking the images, I do that. That way you can see when an image changed over time. You can't do diffs to see what changed about the image, like, oh, we added a picture of a cat into this one other image. You can't see things like that, but you can see, like, in this change set, somebody updated this image. In this change set, somebody updated this image. So you can see when in the history the image itself was changed. Also, it makes it nice for when I push to GitLab, we have auto deploy set up. So when I push it to GitLab, the image is in the repository, it doesn't have to go find it from somewhere else, and it can just push it straight to the website. All the images are included. We do things like PDFs also, because they go on the website, but things like email blasts, we generally don't track that. But for images and PDFs and things that are incorporated and part of the website or links are there, we do actually add them there. So let's do git add images / company, get status again, just see what happened. So still in the branch bug fix, changes to be committed. So this is added to their staging area. Git commit to add it to our repository. Add company logo to navigate. Okay, so then since we know the client's going to be fine with that because we know that that's their logo, we designed it for them. We know that it should be in the top of the website like that, and it works. We can see it's there. We can check out master again and merge from the bug fix branch. So git merge that branch into the one we're currently on, and you can see here it just this tells you it did a fast forward. Here's all the stuff that it did. If we had 20 file changes, it would list 20 things there, or 20 separate files. It would tell you how many. So essentially, we went from a binary size of 0 to a binary size of 12,029 bytes. But if we do get status, nothing has changed. Do get log, you can see it literally just, this is the last thing we did on this branch. This is the thing that it just added. So it just literally took that commit, put it on top, and moved the pointer. Are there any questions? So that was kind of it for my demo. I have a little bit of an advanced demo if we want to go into that where it uses GitLab. I don't actually have a demo with GitLab, but I do have GitLab -demo.
You've also, everything you've done so far is about Git essentially standalone.
Yes.
But Git is really a mesh type of arrangement as compared, I don't know what TeamForge is, but like SVN is a client-server arrangement. Git, each repository.
With SVN, you check out a file and nobody else can work on that file until you're done with it, right?
No.
Or is that
no?
That's file locking. That's handled by.
Well, there is a source control system that does that.
There are many.
Yeah.
Right. But SVN, there is a central server. There is a single central server that is where all of the past versions of everything are.
Yeah.
Your local copy has a sandbox, which is essentially the same as the current branch. And I don't know what the hell they call it anymore, but basically the previous revision.
Okay.
If you have no internet access, all you can dick with is the current working copy and the previous revision. When you do a commit, it takes this mess and sends it back out over the network to the server.
Okay.
If you want to check something out, it has to go to the server and get that thing. Whereas with Git, inside of that Git directory, you have the entire repository. Now, if you have two people,
you can just get the most recent revision.
Yeah.
If you have two people running Git, which this is the part you haven't addressed, just like SVN, this guy can go grab stuff from that guy, or vice versa. And if you have three or a whole web of them, that's something you can't do with SVN.
Yeah.
Because there's only one server, and every client only has the current work last time they checked out, okay, which might be different from what's over on the server, plus the immediately preceding that backup. Now, one other thing is Git talks SVN.
Yes. There's a plugin to do that.
Yes.
-SVN.
So I use Git all the time. I am not as proficient as you. I learned a bunch of things from you. Okay, thank you.
Okay.
Very good. But I use Git all the time, and oddly, a large percentage of my clients use SVN.
Okay.
So I used to know a lot about SVN. I forgot almost everything I know about SVN, except that Git space, SVN space, what is it, update or something or other, pulls everything from SVN into my current Git repository, Git space SVN decommit, sends it all back to them. So I do all of my get things like I normally do all of my get things, and then, you know, maybe at the end of the day or the beginning of the day, I push them over to the SVN server or pull them back from the SVN server. Now I don't have to know a damn thing about SVN except for 2 commands: push, pull. I mean, that's not the name of the commands, but regardless.
I get what you're saying.
Okay,
But
and the client doesn't know I'm not using SVN.
Pushing and pulling are actually
They're
Git commands, but that's so essentially you have a server, and I'm going to set up here client A or whatever.
And while he's doing this, forgive me, you don't have to have GitLab or GitHub or Git or any of the variations to use Git with a server. You can actually just tell it a remote location on your file system or on the network. And
another Git repository is another, it can be on the other end of the network, it can be 2 directories over.
Right.
Okay.
Like I was working with Windows one day, and we had we had Samba share that was write protected to only the IT department, and we would do our work here and then push to the network share.
Right. The other thing that we haven't addressed, but is actually central to a lot of open source projects and definitely central to Linux kernel stuff, is you can not only have multiple Git repositories that are all tied together into this web, but they don't even have to have the same damn shit in them.
Yep.
Okay, there's a Git repository for wireless, Linux wireless. There's a Git repository for Linux serial. They have the current working crap for the wireless people. All of the people who are working on wireless are connected. They have their own private copy of Linux wireless. When they're ready to do something, they make a commit. They push it up to the wireless Git repository, which is only about Git wireless. And every so often, those guys say, "All right, well, I'm going to push it up to Git networking." Okay, and then the networking people sit on it for a while and play with it and test it, and then those guys send it to Linux Next, and the next people play with it and test it and say, yes, this doesn't crash and burn and do evil things all over the place, and they push it to Linus, and then it becomes part of 4.9 or 4.10 or whatever the hell we are right now. I don't know.
10 is the RC.
But each of these repositories, they're all different, but they're all interconnected into a mesh that can...
So the Atom text editor that I use has a very similar structure. So they have like... So like this tree view over here is its own repository.
All right.
So tree view is a repository. The editor itself is... the core is a repository. But if you go to the packages here, like each one of these is their own repository. So like bookmarks is a thing you can do inside of a file. You can bookmark different lines of a file. Like the bracket highlighter is its own package. You can see each thing has its own thing. But Atom, it's in the Atom like user space, but it has like the command palette is its own project. And then whenever they like build it to deploy, they just like pull this, build it, ship it. Like that's just how they do it. So it has a very
kind of
very similar structure
to Git.
Yes.
Yes. Well, it was built by the people at GitHub. So, yes, it's very, very centric around Git.
Well, it was actually originally the ACE editor, and then they built Atom on top of ACE.
Okay.
And then absorbed the ACE-T.
And then
So they
rebranded it as Electron. Yeah. So Electron is like the Chrome shell, and they built it inside of that.
The other thing Alex didn't address is we did do this inodes versus names things, and that's very real, but you also dealt with the essentially the inode names, but the inode names, what do they call that, tree-ish? Is that what it is? Isn't that you don't have to have the full, huge string. You just have to have enough to be unique.
Yes, exactly.
Okay.
Yep. Oh yeah, it is called tree-ish. Yeah, I know what you're talking about, yeah. Yep.
And you can, anywhere where you can use a name, you can substitute
so if I do git log, and let's say I want to check this out, I can just copy like the first 10 bits. I don't have to copy the whole thing. I can just copy the first 10 because I'm assuming that that's going to be unique enough, and then I can do git checkout, and then just that short little piece, and it'll go there. It says, see, it's complaining because I'm in a detached head again, but like I am here.
Right.
If I do
git log here,
git log, yeah. it did check out, this is the top, this is the tip of the branch, and it has everything before that. So you just have to have enough of this to be unique. Starting at the beginning, going to here. I mean, I could, since we're so early in the project, I could probably get away with like, you know, just a couple.
DB1. Yeah.
DB1 did not match any file paths.
Because you have to have enough.
Not quite enough, but DB1, DB, there it is. Okay, so I used 5 is unique enough.
Right.
Like, but
Because nobody in their right mind wants, I mean, even if you're cut and pasting them, that's a
Yeah, yep.
shitload to cut and paste. And, you know, fine, you missed the last couple of characters, who cares? We'll get it straight.
But another cool thing is, since there's different branches, if you think that that pointer is very important to you, you could either alias that checkout pointer, or you could just make a branch, go back there, and then that branch is then a pointer to that slot.
Right.
Right. And you can tag a specific commit,
Uh-huh.
so you can give that point in time a name.
Yeah.
And then you can actually check out that tag,
Uh-huh.
and you can create a branch. Then from the tag, it will create a full-blown branch that you can then do features on
Right.
top of, or you know.
That's one thing I haven't
security
gotten into was
fixes and
tags.
Things
I
like
haven't
that.
done much with
I
tags.
can explain
What-
branching and tagging and all the fun stuff at another day.
Okay.
Well, I was going to say, what the hell is, I use them both, but in SVN, well, I don't want to say they're fundamentally different, but they're fundamentally independent.
They are fundamentally independent. Putting a tag in Git is literally going, this thing has that name.
But that really is also what creating a branch is.
Yes, but there's a difference.
Okay,
A,
I mean,
a
you
tag
use them differently
is
by
an,
choice.
is an immutable point. It's literally only a name for that commit. A branch, you're actually saying, I am a branch, I start there.
Uh-huh.
That's what a branch is.
Right.
I'm a branch, you're going to do things to me, I start over here. A tag is,
Branches are
that's
beautiful. Whenever you make
V1,
another commit, it
can't
will.
touch me.
The branch pointer will update. So let's say I have a commit, I make a new one, the branch will say, okay, now I'm here. I make another commit, okay, now I'm here. Whereas a tag is, this commit is
Right.
version, or whatever.
But they're both links to commits.
They're
but the
both
branch
pointers,
commit,
the one like you
I'm sorry,
say
they're both
is immutable.
links,
Yeah.
pointers.
Yep.
All right, but the tag stays attached to whatever it was attached
Yes.
to. The branch moves as you make changes.
Yes.
Yes, and a
All right.
tag will actually, if you check out a tag,
That's a
Git
good
will
understanding of the
refuse
difference.
to make changes. So you can't commit against a tag.
Right, all right, that would be true.
You have to
That
check
would
it out as
definitely
a
be true.
branch.
If you check out a tag, you can create a new branch. You can modify things, but you can't recommit to that tag.
Uh-huh.
You can recommit to, all right, that's,
Right.
the-
So you can
Good.
actually do like git checkout -b branch name tag name, and it will create a branch from that tag.
all right.
Uh-huh. So some software, I'm trying to think of, I was just working on something the other day. Atom is a great example. So in Atom, whenever they make a tag name, that's like the most recent release, you can always go back to whatever that release was. Like let's say I'm on 1.13.6. If 1.13.6 doesn't work, they have a tag 1.13.5, and I can just check out 1.13.5, build Atom against that, and I know that that was a working, stable release at that time. So you can go back to different versions of software. So software uses it, and 1.13.5 is never going to change. If they change that, then you need to make a new tag name, 1.13.5-2 or whatever. So the tag, you know that tag will always point to that thing. So for software versioning, it works great because it's never going to change.
The other thing that I guess that you haven't addressed, which I do a little bit of, but not much, is that Git works in Windows.
Yep.
Well, you did mention that at the beginning. We
Yes.
haven't shown how to do it. I guess mostly you've been using, and mostly I use Git from a command line.
Yes.
There is 2 Git GUIs that are like.
Oh, there are way more than 2.
There's a couple of very good ones actually.
Uh-huh.
First off, you can do it from the command line, and even the tools will rely on certain binaries from the command line. There is, for example, Tortoise SVN and Tortoise Git, which
Right.
actually integrate with Explorer.
Right.
However, there are also extensions that work with Visual Studio that build in added functionality. There are also products like Git Tower and
Source Tree is one of them.
Source Tree.
Git Kraken.
Yes, Git Kraken's a popular one.
They recently changed the licensing though. It used to be free for everything. Now it's only free for
Yeah.
non-commercial projects.
Yes, that's why GitLab did not partner with them.
Uh-huh.
Yeah, but anyways,
That's
You-
why
you
Git
uninstalled it?
came
Yeah.
about in the first
We
place.
were using that at work.
It's because BitKeeper.
there's many visual tools that will help you understand how branching and commits and everything actually work for evolution over time. So you don't have to do it all from a text editor and trying to figure out the links and diagrams and all of that.
Over the past probably about 5, maybe a little bit more years, the vast majority of open source projects have moved from SVN as their source control system to Git as their source control system.
Yes.
There's just still a few that use SVN. There's still a few that use Mercurial and Bazaar.
Mercurial is
Yes.
pretty popular also nowadays. Yeah.
Yeah, but not nearly as
Not
Git.
nearly as popular as Git now.
Okay, it's Linux. There's always somebody doing 10% of the slightly different with a whole bunch of us weirdos who go, no, that's the best one in creation. Why would anybody ever use anything else? You know.
Which is the nature of
But
it.
so I had mentioned at the beginning that Git is distributed. So we've been doing everything on my laptop, and this is a web server running in a VM on my laptop. But I could have had my laptop. I'm technically on Wi-Fi, but that doesn't really mean much because you can't get to anything from here anyway. But I could take my laptop on an airplane, totally disconnected from the network, not connected to anything. I can make my changes, make my commits, and then when we land and I connect up to like the central repository, which would be like GitLab, when I connect back up to that, I can just push all my changes. I don't have to be connected to the network. It's the difference between
Right.
SVN.
That's-
I don't have to be
that's a-
connected to the network to do my work.
Now, there
I can
is-
make my work, make commit, and then when I get back, try and merge my branch.
There is actually an add-on for SVN called SVK,
Uh-huh.
okay, that makes SVN work like Git does. But by the time you start playing with that, number one, your SVN is off in the fringe now, and SVK is in the fringe of SVN, and it's just go use Git. You know, Git will talk to SVN perfectly fine. You don't need to use a weird, but there does exist a version of not a version, an add-on for SVN that makes it kind of Git-like where you have offline repositories.
But just to go over GitLab real quick, so this would be like where the central repository is. Git has so we have a couple of Git commits that we went over that I didn't really name, but master is one of the conventions. That is like the main branch. Also, head was another one I mentioned. So origin is another keyword that it uses, and that essentially means like the centralized location. You can name a remote branch anything, or a remote.
A remote, anything you want.
Yeah, I guess it would be called a remote. I'm like, what's the name for that? Yeah, you can name a remote anything you want, but here it defaults to origin, letting you know like this. So this is the centralized spot. So GitLab is very nice that it just adds like these commands out here, like where are you? Are you creating a new repository? Do you already have an existing folder? Do you already have an existing Git repository? Like it tells you like all these things, and then you can just copy and paste it. So CD to the existing repo, and then we're just going to copy all this, and you can just paste that into here, and it just added. So if you do Git remote, you'll see you have origin. If you do Git remote -v, it'll give you a little bit more information, and you'll see, so for pushing, you push here. For fetching, you fetch from here. That's cool if you have some kind of master-slave setup, but since we don't, we just, both of these origin for pushing and fetching are this, GitLab at, GitLab demo, AMAR, so this is the folder then. But we have all that here. So since we added our remote, you'll notice that under the project there is no, there's no activity. There is nothing. I was going to say, so there should be another tab
normally
after
is
you
a
upload.
repository when you push.
Yep. Okay.
There's no files.
So to get the things there, you'll notice that it says add that repo and then push all tags. I'm not sure why do you have to push tags separate.
Because you have to tell it specifically that I want that. You can technically say all and tags.
Okay.
If
So
you-
I'm just going to do push-u, which means like link these, track them together. Origin, master. So I'm pushing the master branch to origin, and I also want to name it master. You can also change the names, but the U just means I want it to track. So if you ever do a git pull, it'll say origin master is ahead or behind your current master here.
The dash U is short for upstream.
Yeah. So there, I just linked it. It tells you a bunch of stuff. It compressed it, blah, blah, blah. Here's a new branch. So a new branch was created there. And here's master. There's also called master.
And then your
And
local
it was
branch
set up
has
to track the remote branch from origin. So then if I go here and I refresh this, you'll see now I have a repository tag here. But you can see all my commits. These are all the commits I made. Here's the crap one Jason made.
Or
You
the
can
stuff
see-
you're blaming Jason for.
Yeah, the stuff I'm blaming Jason for. So you can look at the files here, and you can even go back to, if we had multiple branches, you could look at each different branch, or you can even go to the commits here, and if I want to look at this, and then look at the files here, I can look at the files as it was in that commit. So I can go back here, and you notice like there's all this stuff misspelled, or this is actually the one right after we change the spelling. Whatever. If you go to here, and then go to browse files. You'll notice that it's not.
What are
I
the
keep
rules
clicking
for
on it.
GitLab?
What is that?
What are the rules for GitLab?
What do you mean the rules?
You want to put stuff up on GitLab.
Well, this is a self-hosted version, so this is actually running on my laptop.
Oh, all right.
Right.
Uh,
So there are public and privates that you can use. And
So I can take a server in my space and put GitLab on it and point my
Yes.
clients at it.
Yep.
Now I can do any damn thing I want with it, and I don't have to worry about licenses or monthly fees or anything like that.
Right.
All right, but
That's for
if
the
I wanted
community.
to put-
That's for the community edition. They do also have an enterprise edition, which gives
Okay.
you slightly extra features and support.
I'm not likely
What?
to. I'm barely going to know how to use the community edition.
Okay.
But now I say I don't want to do it myself. I want to do it on their systems. I know I have an account at GitHub. I've barely used it, but I'm sure GitLab is the same. There's a limited amount of things that you can do basically for free. What are the rules for that?
anything you can do on the community edition, you can do on GitLab.com for free. If you want to have a private repository, that is not a cost on GitLab. The only time that you want to get into paying for some services on GitLab.com are clearly defined. But general rule of thumb, unless you need those features, you're not going to pay us a dime.
Mm-hmm.
Because
I don't care
be
about
flat
paying you a
on it.
dime. I just have to know when I'm going to have to pay you a dime.
And I would actually have to pull up the specifics of what's needed to have a paid account.
Mhm.
Because I've never had to bother with that.
Yeah, so we have a self-hosted
Support
edition.
primarily?
Hmm?
What supports you primarily?
A significant portion of our income is entirely enterprise customers.
All right.
So managed hosting in local installations, things like that.
So I use the community edition. At work, we have the community edition installed, and you can have private repositories on the community edition. Like if you went to our GitLab GitLab URL anywhere outside of our company that you aren't logged in, there would be no projects. You wouldn't see anything. So if you log in, you can then see all the projects.
Go click on the gear for the project.
What do you want to go to?
And edit project. Project visibility. Right there.
Where? Oh.
Project visibility. Sharing permissions. And you can say internal, private, or public. Internal means that it's something that belongs to the group. Public means anybody can get to it. And private means it's mine.
Now you can make it private and then also invite other people to be able
Yes,
to edit it.
because
You can
you're
also make
specifically-
it internal and invite people from other groups to be able to edit it.
Right. There's a way to define internal
Just
users
for an opinion.
and external users.
Your
So you can individually set it that way.
We really should get the camcorder for this, but I mean we're about
So,
time.
We're pretty much, yeah, it's 9:12.